Welcome to the second webinar, and I hope you all had a great lunch. I know I had anyway. This is a webinar for traffic signals, which will last to about 90 minutes. And my name is Thomas Sjöström, and I work at Sweco, and I'm very pleased to moderate this webinar and introduce to you some of the top European traffic signal experts who really has a burning passion to develop and implement CITS services. This webinar has two sessions. The first will cover traffic signal information, and then the second part of this webinar will cover traffic signal priority. And some netiquette. This webinar is being recorded, and the chat will be open during the presentations, meaning that all the participants, the audience, can write questions during the presentations. And then at the end of each session, we will have a Q&A session. So then camera and audio will be enabled. So if some audience would like to send a question, you could present it with audio and video. Okay. So the first part here, the traffic signal information with topic on the road to deployment of CITS traffic signal services into the Nordic countries. And this flagship has been exploring and piloting how to provide reliable predictions in the Nordic countries, where we have a lot of traffic accuracy signaling and where public transport is prioritized over the cars. And we will have 3 speakers, and I will introduce them at the same time as a team, as they have been conducting this pilot. And the first speaker will be Örjan Tveit, covering the traffic signal information flagship topic. And Örjan Tveit holds a PhD in traffic engineering from the Norwegian University of Technology from 1999. From 1999 to 2010, he was a senior research scientist at SINTEF. And in 2010, he joined the Norwegian Public Road Administration as a senior principal engineer. Örjan has been responsible for the Norwegian pilots in NordicWay 3. And then we move on to the second speaker of this session, which will be Christina Bäck Jensen. And her topic will be connected traffic signals projects in Gothenburg. And Christina has a long experience from leading IT projects within CITS, connected traffic signals, traffic management, business-to-business e-business, federation, and system integration. Since 2017, she has been a project manager at the city of Gothenburg, working with connected traffic signals and develop and implement data sharing solutions between the city and external public actors. The third speaker of this first session will be Mikael Ivari, and his topic would be connected traffic signal as a driver for new mobility services. And Mr. Mikael Ivari is a senior advisor for the Department for Urban Environment at City of Gothenburg. Mikael has more than 10 years of experience of working with connected and automated vehicles from a city perspective. He is responsible for developing the strategic agenda within the fields of vehicle automation and digitalization, and has more than 20 years of experience in urban planning and innovation, working both in the public and in the private sector. So, with these words, Örjan, please, I leave the floor to you.
Thanks for the kind introduction, and I will try to start. Oh, what happened now? I tried to take control, but I didn't think it.
Yeah, you can try again.
I don't know what's happened now.
I think you should ask control, and I will provide it to you. I think you have to just click the button there, take control.
I did. Sorry, I did that, and
maybe you were too quick. Sometimes when you're too quick, it doesn't really understand.
Yeah. But can you perhaps change for me, because
Yeah, absolutely. I will do that.
so you can take the next picture, because I got
There we
up
go.
some. Okay.
Oh, now the presentation disappeared.
Sorry. Take it up.
Let's see here. Alva, could you please upload or share the presentation again, please?
Yes.
Yeah.
Can you see my screen now?
Actually,
Maybe
I
soon.
cannot. No. This is like Darwin's law, you know.
Yeah, we had some
And you know who
problems.
Darwin's disciples were? They said that Darwin was a really optimist. Yeah.
Can you
So-
see my screen?
Yeah. So I
Perfect.
can change.
Please do that, because I think that the way I come into this meeting didn't function totally. So
Okay.
please change.
So, yeah. So please, Örjan, go ahead.
I'm still seeing the first slide, the webinar traffic
I
signals
think-
agenda.
Thomas, you have to take control again.
So now,
Yep.
does it work now?
Yeah, it works now, but can you take one back? Because this is not the first one. There you
There you
are.
go.
Thank you. Thank you.
Okay.
Sorry
All
for
right.
this problems. But
No problem.
the focus here is how to provide traffic signal information into the car. Perhaps not the way that is shown here, but we are focusing especially on traffic actuated signaling that we have a lot of in the Nordic countries, and that's the focus of what we have been doing. Next, please. What do we actually share with the vehicles? We are sharing two standardized messages, spot them up, and I think that we can start with a picture, because that shows what we are aiming for. We can show if it's red light ahead of you, how long it's going to be, and if it's green light, how long it's going to stay, and what sort of speed is recommended at these intersections. And that is the spot message, and the map message is the path towards the stop line, so that the car can recognize where it is, and also recognize when it comes to the stop line and what's going to happen when it comes there. So that's the two messages that makes up the basis for this functionality that we are working with. Next, please. We have started especially with prediction quality versus adaptive signaling, because that was the basis that we were thinking about. And the natural starting point for predictions is, of course, the supply of traffic signal equipment. In Norway, that is mainly Svarco, and we have tried to change original vehicle actuated signaling towards something that is more predictable, because based on the intersection and the fluctuations of traffic, of course, it can be quite varying how the signal is set up and how long the different stages are how long they are. So we tried to change the software and the controller, and actually we went through 7 steps, and at the end we ended up with something that was near fixed time. It wasn't fixed time, but it was near fixed time, and we did improve the prediction quality, but the problem is that we also decreased efficiency in the intersection. So the conclusion was that we needed to have some other arrangement, some other way of doing it, and that means that we needed to have some more powerful algorithms for prediction. Next, please. So what is a prediction quality? A prediction quality is some sort of how accurate does it fit the prediction that we are giving, and it's not rocket science to actually find out if it's good or not, because if you are given a prediction, then 10 or 30 or 60 seconds later you get the real result, and then you can compare. A good service will have up to 95% of predictions within a few seconds deviation, and that's the green and the yellow area in this slide here. Here we have on the right 1 second to the shift and forward, and actually it ends up at 60, something like 60 seconds, and then it's quite far away. But one more, please. When it looks like this, it's not so good, as you can imagine. The nearest is okay. The 6 or 7 seconds is okay, but it's not so good when it comes to further away. Next, please. So what we did was that we took started with the traffic light control on the left. We send all information through the control system that we have. Either we could make spot map messages in the control system, or we can share the basic data like cycle data and detection. And then we shared either cycle data standardization or spot map messages with traffic technology service. That's a third-party company that is making predictions based on the status on the intersections, and that's sort of another solution instead of using Svarkod as we did previously. We have sent our messages towards the sign or to the NordicWay 3 interchange, so that we can share that there, and then we have assigned it's a message. And we also have tried to send a non-instant message to vehicle cloud manufacturer, so that we can share it with actually customer cars. Next, please. In our setup, we tried another way as well, and that was to share the information with a company that's called 4C. They made an app that was integrated into Polestar, so that was so that the images were integrated in the car, and the message was in the car, so that was more safe. But the main purpose was also that when we show information in the car, we can also get information from the car where it is, the speed, if it's using the brake and so on, so that we can get a data lake showing all events that happened, and we can use that for evaluation later. Next, please. We have been working with 3 areas together, that is Göteborg, Oslo, and Trondheim. And one of the nice things is that we have been working both with the solution into Polestar, but we have also worked with TTS, the company that provides information to automotive OEMs. And I think that within this week or next week, customers' cars from Audi will receive this sort of information into their cars from our Nordic countries, and that's the start of a service that will live on from NordicWay 3. Next, please. Here we see a picture that shows the integrated service in Polestar. So we are using the infotainment window to show what's going to happen when you arrive at the stop line. If you go straight or right, you can you will arrive at green, and if you're thinking about going to left, then it's red when you arrive at the stop line. Next, please. We use the information gathering from Polestar to see how the people react to this sort of information. This survey shows the stated information, how they think they would react, and then we can compare it with what they actually did. But what we see that they think that if they get information, they will change their speed towards the intersections as the upper left. They think that there will be benefits from giving this information as a whole for all users. At the left bottom, they say that they would prefer not to have it in the infotainment window, but actually in the dashboard. And then there was about the dashboard contra the heads-up display, and I think that was a bit difficult for them to answer, because perhaps not everybody has tried a head-up display. But I think that it's important to have the information on a very visible place. Next, please. So what we have seen from our testing and so on is that there are some takeaways here. The Nordic way of setting up traffic signal or that is actuated is problematic when we are making predictions. We might lose some of the flexibility if we in the future would accommodate autonomous vehicles. The ecosystem and business model for either public or user payment is essential for the rollout process, and traffic signals information is perceived as a user-friendly ITS service. And that's what I thought of presenting this time. Then take it away, Thomas.
Thank you, Jan, for a great presentation. So we now move on to Christina. And Christina, would you like to try to take control of the presentation? See, Christina, you're muted at the moment.
Yes, I will go ahead and try right now. See if I get the control. Seems like it might have worked.
Yeah, seems to me. So then I give the floor to you, Christina.
Okay. Hello, everybody. My name is Christina Jensen, and I work as a product manager in the city of Gothenburg. And I will take you through this pilot that I've been leading. So this is a Gothenburg pilot, but it's part of the traffic signal information flagship. So here we have the 3 roads where we have installed connected traffic signals in Gothenburg. We started out with a blue one in the bottom, the Sahlgrenska road. That one we did in the NordicWay 2, connected 5 highly adaptive intersections. We continue with the green one up to in the left corner. And here we have 3 fixed time intersections and 1 adaptive. It's Jan och Branting. And during the last 1.5 years, we've been working with Delsjövägen, and that's a corridor of 15 intersections, highly adaptive. This is our largest one then. We've been putting a lot of energy into this last road. And this is to visualize how the data was shared in this project, focusing on the green part then. The Gothenburg city sent raw traffic signal data and topology data to ITS, who is a CITS service provider, as you heard Örjan speaking about before. We used the same, so we were very grateful to be able to do that. CITS produced SPAT map and predictions, which could be downloaded to the Polestar cars and used to in their glosa functions. We also have a gray part here, and this is supposed to symbolize our vision, the city's vision. We would very much like to share this data via an interchange instead, to enable a lot of different service providers to download the data and create CITS services of different kinds, and also then that they could distribute the data to many users and OEMs and back to us as well. I think this would be a very good structure and would make it easier to scale up. In this project, we had a lot of data quality issues. It's a huge lesson learned that ITS services require a very high quality data. And today's legacy systems, they are often designed for human users. So it means that we don't have all the details in the documentation, all the details that is required for CITS services. So we had to go back to square one. After a few months' work, we realized that there are too many issues. We need to do something about it. So we stepped back to square one, started updating this traffic signal documentation, such as signal plans, detector tables, switching schemes, and so on. And in the end, we reached a quite good result. There are 3 different prediction methods. We have the fixed time engine. We have the emulator, same as a virtual signal controller, and we have the AI method. And the AI method is based on a self-learning algorithm. And this is the method that we primarily used in Gothenburg. We only used the fixed time engine for 3 intersections in the Hjalmar-Branting route. And this is a funnel chart, an example of a funnel chart. You saw it before in Örjan's presentation, and it shows how successful their predictions have been during a 24 hours recording using the AI method. And this is for one specific intersection, and the green part means that the prediction is exactly correct, minus plus 1 second. The yellow part is very small, but there is some yellow, and it's minus plus 2 seconds. The red part is minus plus 5 seconds. So the green part is definitely to prefer. So to summarize findings in general, well, we could see that we really did understand that the traffic signal documentation is not accurate enough. We need to update it and add all the details like push buttons. All push buttons in the detector tables need to be there. All signals needs to be in the signal plans, even the fictive ones, and so on. We could also see that these intersections were quite representative for Gothenburg in general. We do have a high degree of adaptive signals, and bus and trams are often prioritized over cars and pedestrians. And they are also very highly adaptive to requests from side roads. When it comes to correct predictions, we had a variation of between 80 and 99%. Delsjövägen scored 90%. We worked with that part also much more than the other parts. Sahlgrenska scored 80%, and Hjalmar-Branting scored 99%, because they were fixed signals. And it's not so difficult to make predictions for fixed signals. 88% was for the adaptives intersection. And common reasons for intersections with lower accuracy is usually tremendous complexity. Either there could be many road users or many different kind of road users. And another reason is that we very often have instant reactions to pedestrians and side roads requests. So yeah, we also had a pilot test driving in September together with Statens Vägväsen Norway and Polestar. And the result from that day was very good. So we were correct on about 90% of the time. But we also concluded that incorrect predictions is not really a big impact on customers' experience in this case, since the service was not displayed when the confidence value was not high enough. So it means that you only see the good predictions in the car. Yeah. The most frequent reasons to incorrect predictions in this case was that pedestrian triggered push buttons, or that public transport was prioritized, or that it did not move in an expected time range. So is there any room for improvement? Yes, we do believe so. We can optimize the traffic flow by using real-time strategies and signal settings. The way we were working with Delsjövägen, we could work even more with that if we would like to. We could also maybe delay the intersection reaction time in some intersections. Maybe it could be worth adding a few seconds to pedestrians in some cases, who knows? Maybe, I mean, if it benefits the whole traffic situation, could be worth it maybe. We could also try to get public transport requests or calls from side roads earlier. So the next steps in this, we think that we should identify which intersections has room for improvements like the one I just mentioned. And we could definitely start updating the traffic signal documentation, our signal plans, detector tables, switching schemes. And finally, we do need to establish a local access point for data sharing to reach an efficient data sharing. We need that. Right. Thanks for listening. And now I will hand over to Michael Ivery, my colleague.
Thank you very much, Kristina. I will you release control of the presentation so I can try to take control over it.
Done now. Can you try to take it?
Maybe. Now it works. Yeah, I
Yes.
changed the slide. Okay, thank you very much. Oh, it works perfectly. I see speaker's view, but you see only the presentation, right? So we have a full screen.
Yeah, that's correct.
That's good. Okay, so thank you very much. I will, as the final part of the presentation of this first part of the session, I will talk a bit about connected traffic signals as a driver for new mobility services. And then I will start to try to explain to you why CITS is important. And we didn't realize that 10 years ago in the city, but about 10 years ago, we were introduced to the concept of automated vehicles by Volvo Cars and some other partners. And while starting to explore the theme of automated vehicles, we pretty soon realized that it will be very important to establish communication in order to facilitate orchestration in between different modes of traffic. And that means both vehicles and vulnerable road users. And soon after that, we stumbled upon the concept of coordinated CITS. And coordinated, in order to be coordinated, you need to have connectivity in place. And then we started to think about how can we plan for a theme such as automated vehicles that is so very scarce today, and how can we justify investments in preparing for these kinds of vehicles. And then CITS emerged as a very important technology bridge, because with CITS you can gain benefits by communicating with the vehicles already today while still preparing for the future, for the advent of the autonomous vehicles. So that's when we started to develop what we call a long-term strategic approach, which is the pyramid to the right in this slide. We need to have connectivity in place in order to facilitate coordination that will allow for the safe and sustainable introduction of automated driving systems and eventually fully autonomous vehicles. And the foundation for this is digitalized work process that are able to produce data in a machine readable format. And this was actually formalized in 2020 when at that time the Urban Traffic Committee decided upon our strategic plan for traffic innovation within the fields of electrification, digitalization, and automation. Christina mentioned NordicWay 2, and that's where we actually started exploring the concept. And at that time, we took on many roles at the same time. We were not only the owner of the traffic signal controllers and producing high quality traffic signal information, but we also made the predictions ourselves. And we put forward a pilot which had excellent technical qualities. We had very low latency, but we realized that it would be very challenging and perhaps out of scope for us to be developing very good predictions because that is very complex, as Christina already mentioned. So that's why we were very happy when TTS entered the scene in the NordicWay 3, and then we could change our role, going back to only focusing on producing high quality traffic signal information and leave the predictions to TTS. So that shift has been taking place, and also over these years we have seen the emergence of an ecosystem taking place. We have been focusing very much in the NordicWay context on developing technical solution, but at the same time there have been many legal advancements within Europe, and there has been an updated ITS directive and an updated RTTI delegated regulation. And those legal requirements put forward that national access points should be established. And that is very important because we need to have something that facilitates the communications between producers of data, such as the city, and consumers of data. And that has to be done in a safe and transparent way. So this digital communication infrastructure is very important to put in place in order to facilitate the exchange of data and different types of services, because we see it as a platform for multiple types of services. Today we're talking about connected traffic signals. Tomorrow there will be a presentation about geofencing, and we have also been part of piloting and developing quality of digital regulations that will enable geofencing services within the NordicWay context, and you will be able to hear more about that tomorrow. But these are two examples of digital regulations that would benefit and could make use of this communication infrastructure that is slowly emerging across Europe. These are the first stumble steps that we see that are taking us towards what we call a phygital future. That is where the digital future is blending with the phygital environment, with the physical environment, I would say. And this is really exciting for us because this means that we can close the loop, as you can see in the picture ecosystem to the right, the orange arrows. This means that we can make use and develop new services that not only rely on us as a public authority giving rules for users instructing them how to behave, but we can also make use of vehicles as sensoring platforms, and they can provide feedback to us about if the digital relations that we share through the access point, if they are correct, or if anything has happened. So we can have a 24/7 update of the status. And this opens up for more qualities in what we call the digital twin, that is also emerging in the city of Gothenburg, but also in other cities, where you have a digital replica of the city that provides for a lot more new efficient services. So I can see our time is up, and I want to thank you very much for listening, and we're happy to take any questions.
Yeah, thank you all speakers for the first part of this webinar. I have one or two questions in the chat, but I think some will save at the end of the Q&A for the next session. But meanwhile, as the tech room produces the next session slide, I have a question for you, Mikael. What does it take for a city to deliver the CITS services?
Yeah, thank you for that question. One very important thing is that we have consumers of these services. That is, we need to be connected to the users. And that is first and foremost. And the way that we have shown how to do this in the Nordic Way is making use of the interchange as a concept. And I think this is very, very important to put in place. And we know from the different actors that have been taking part of this project that there can be no Gothenburg connectivity solution, or not even a Swedish nor a Nordic solution, but there has to be a European solution in place. And we're seeing slow but gradual steps in that direction, and that is very positive. So that is first and foremost. We need to have this infrastructure in place in order to connect producers and users of data. Then there are further challenges, as Christina mentioned, and so on. But we start there and we stop there.
Thank you very much for the answer. I think for now, due to time, we need to close the Q&A, but I would like to thank the speakers for the first session. And please enjoy the second part of this webinar, because we will have a Q&A at the end of the second session, and perhaps some questions will be directed to you.
Good.
So, yeah. So with these words, we're now moving on to the second part of this webinar called the Traffic Signal Priority Solution. The focus is mainly to discuss the positive impact of deploying a technology-ready, standardized traffic signal priority within the cities as part of the CITS ecosystem in Europe. And we have several speakers within this session. And we will have the first speaker from David Otterdahl. And he will, and David Otterdahl works for the Swedish Transport Administration as a specialist of roadside equipment. And David's focus includes communication protocols between central systems and roadside.
Thank you, Thomas.
Yeah.
Can you hear me?
Yeah.
Great. Let
Have
me
you
try to take control. Great. I think it works. So I will go to the first slide.
Yeah, I think there was some mix-up. I think you can skip this one, and next
Yes.
slide should be your start.
Yeah.
Here we go.
Here it is. Thank you. Well, I'm here to talk about the requirements of the traffic signal pilot as a road authority. And our expectations on adopting the CITS architecture includes that this provides a standard method of exchanging CITS messages. And that means that there is no longer need for any specialized equipment in each intersection designated just for the priority functionality. And also that it makes it possible for us to enable priority anywhere when we need it. Today, technical solutions for enabling priority is often different in each city or area, and this can result in increased costs and risk for errors that can be difficult to troubleshoot. But also we need to find a working solution which is compatible with our existing systems and priority functions. If we need to replace many parts, it would make deployment very slow and time consuming. And that is something we'd like to avoid if we can. Yeah, there are some challenges though. It has been difficult to find and interpret the standards and relevant documents. There's been many cross-references. And also the map and process needs to be implemented and tools needs to support our workflow. We also need to ensure that our own documentation is up to date. And there might be some work to do in this area. There's also differences between the ETSI and the C-Road standards and how our existing priority systems work. And that means that there's a need for a translation layer between the standards and our existing systems. But the translation is a compromise and it isn't perfect due to these differences. Let me see if I can change. Yeah. Well, our findings include that the architecture can be implemented in several ways, at least from a road authority's perspective. We would like to avoid adding or replacing equipment in each intersection unless it's absolutely necessary in order not to delay the deployment. And we also understand that we need to participate in future standardization work in order to ensure that existing systems and priority functionality that we already have in our intersection, that those continue to work in the future. And we also have identified a need for better guidance of navigating the large amount of document standards and C-Roads documents. Yeah. But focus on the benefits. Implementing priority using a CITS platform gives us early benefits, which is important for us, and we can keep using our existing state-of-the-art traffic controllers. We also think that it's scalable. We can use this standard method in a cost-effective way and deploy it all over Sweden. And we can be flexible and prioritize vehicle in the locations that we couldn't before. And there's more benefits. We believe there's going to be fewer errors since we use the standardized message types, which is machine readable, such as the MAPM data. The priority request message is generic, and it isn't crafted for a specific type of priority technique used by the traffic controller. It isn't expected to contain any special data that might change if the traffic controller is reprogrammed or replaced. We've had issues in the past where we'd like to update the configuration on the infrastructure side, but for whatever reason, the update didn't happen at the same time on the public transport side. And of course, this caused issues. And we believe that these kinds of problems can be avoided in the future. And there's also a possibility for a step-by-step future development when reinvesting equipment and systems with a long-term goal of fully comply with the standards with very few compromises. Thank you. And I'll hand over to Sampo Hinemo at the city of Uppsala.
Yeah, and now it's time for Sampo Hinemo, and he's a traffic planner at Uppsala municipality since 2006. Over the years in Uppsala, he has worked with public transportation infrastructure, traffic signals, and CITS. Since this year, he has been working with the tramline, which is planned to start operation in 2029. So Sampo will continue the presentation within the scope requirements of TSP as a road authority. Please, Sampo, you have the floor.
Yeah, thank you, Thomas. So from the start, we joined this meeting, this project, NordicWay, for improving systems for priority in Sweden and learn more about what you should think of in the today and in the longer perspective, and in the slightly in little longer term, it could help us to improve our systems in the city in the future. And project area consists of 5 single-last intersections with a roundabout in the middle of the area, as you can see here. We have learned a lot of CITS and how to construct technical structures and the importance of standardization, as David also mentioned a lot, is very, very important. There has been some challenges because CITS is not so well known locally. If we would scale up in the future, it is important to give more people insights and knowledge about CITS and why we should use work with standardization and quality and improve processes for data handling. Unfortunately, we didn't have a chance to implement priority in the fleet of the rescue vehicles, but we are very glad to have come this far and created a system solution that could be scaled up. And the findings in the project for us that are important are that CITS supports functionality over undersea border. That means that the bus to transfer one municipality to another municipality could easier be given priority in the future, and that could also help maybe smaller municipalities to join and install priority if they could get help of standardized systems. To reach larger installation, then there should be a national access point to help development. We have also learned that CITS systems could improve priority for rescue vehicles. With the cellular communication systems, priority could be given in the whole city, anywhere. And the process for the priority message could be fully automated from the vehicle to the server environments and then to the traffic signals. So it could be quite big improvements in the future. Yeah, thanks.
Yeah, thank you, Sampo. Really good presentation. And moving from the road authority perspective, we are now focusing on standards and integration of public transport and the road transport system. So we will now hear a presentation from Anders Romell. He is a CTO, Information Technology for Public Transport and ITS Integration Expert from IT and PT. So please, Anders, go ahead.
Thank you. And for those who might not know what IT for PT is, we are a non-profit member organization for public transport stakeholders like PTA, PTOs, vehicle manufacturers, and system suppliers, typically. So let's see if I get so What was our expectations with the Nordic Way project then? Well, first was to spread a common understanding about public transport needs for operating on roads, and to find public transport related gaps in C roads specification, it's messaging really, and to discover integration points needed, like the interchange node or national access point if you want. What findings did we then do? Well, when the development of the APIs, I think that there was not really a common understanding of the public transport behavior and the needs during the design. So potentially there are some small things missing, and also the actual operations of public transport doesn't look the same in the countries, in European countries. So the needs might be different in different countries, and we need to cover more or less all of them. And then another thing that we discovered was there were actually the feedback to the driver in public transport vehicles were not really considered. And since I'm from Gothenburg, that was a key thing in Gothenburg, that drivers actually take important part of the requests and gets a feedback. And as several others said already, the national access point for all intersections details. Well, meaning when planning public transport traffic, we need information about details of the intersections. So we need to get them from somewhere in a standardized format. And potentially then what challenges can it be here? Well, national and EU road authorities need to use the same standardized APIs. We need to come to a common base for the edge users from vehicle side. That's the wide scope, and then there could be narrowed down for sure. But if we're thinking of the big masses of vehicles, it's really important to agree on a standardized API. And also then the local road authorities have to use the same standard. Otherwise, you would not get the expected overall effect, both functional and financial, of course. And then to get a reasonable implementation roadmap, most likely EU funding is needed for in some part. Otherwise, it will take too long time to get there in the end. So what can we do then? Well, you can do a readiness level analysis per European nation of how mature the nation is to implement one standard like C roads at sea. Select one nation to perform a nationwide proof of concept based on the readiness level. And this is to important when showing for other European nations that this is the way forward, to have a larger working proof of concept, the selling point. And then for more national thinking, but make sure that public transport and road authorities' needs are adopted into the existing C roads and standards, meaning that those stakeholders need to get activated and actively contribute and work with those standards. And then I think that we need to evaluate the integration points between road authorities, PTA, PTOs, ETS suppliers, potentially vehicle manufacturers from a national perspective to get the structure set up in a good way so that it scales well, and the stakeholders do get their hands on the needed information, but it also opens up for vehicles to actually have a centralized point to share information with road authorities. So what's our plan then? What do we do to help this, to help our members?
1 minute, Anders.
Yeah. So we are planning to launch here a requirement work group that we will create use cases to see that we get the correct functional requirements and could participate in the standards and technical specifications to help out what is needed in a public transport vehicle in a tender. So you can put those requirements in the tender. And also investigate how we can share data with road authorities in general. And we will see how we can adopt our existing driver API to support the needs of signal priority better. And of course, actively, we will then engage in various standardizations. Well, the conclusions: to see the full functional as well as financial effect on the standardization, it's important that all stakeholders in the chain follows the same concept and standards. Communicate the benefits to the stakeholders, otherwise they don't see a reason to implement it. Do a reasonable roadmap on an end-to-end cost savings basis. And to use harmonized standards is the future. Thank you.
Thank you, Anders. Very good presentation.
Thank you.
That's good. So we're now moving into the commercial perspective of traffic signal priority. And the first speaker out with the topic emergency vehicle priority saving lives is a speaker from EVAM. And his name is Mikael Erneberg, who is CEO and founder of EVAM, which is a Swedish software-centric public safety company. Mikael brings a decade of diverse experience from the public safety industry. So with these words, Mikael, it's yours.
Thank you very much. Yes, I will try to cover a little bit the perspective of our end users, so the emergency services that we have had with us within this project. Short though, before that, a little bit about us at EVAM. We're a fully software company, really focusing on redefining the way that first responders operates. So first of all, some really short facts about ourselves. Looking at the Swedish market today, we're active in 100+ municipalities. So we have a pretty good coverage across the whole country. We're currently active in both the ambulance and fire and rescue segments. So those are the kind of type of users that we will represent today, and have today a really fast growth across the Nordics as well. At EVAM, we're really a supplier of a kind of full on-board software platform. This includes a variety of different types of applications, such as like computer-aided dispatch, navigation, information services, etc. But also from start, we have been focusing on building this out to support different CITS use cases, where traffic signal priority is one of them. So today I will dig in a little bit more into what's in it for the emergency services. So I think there are two kind of obvious things on a high level, which is number one, traffic safety, and number two, shorter response times. So we have, during the NordicWay project, done a little bit of been out on the thin ice to really try to quantify what traffic safety and short response times means for emergency services. So unfortunately, there's very little data available for emergency vehicle statistics on a European level. However, there's quite a lot of data from the other side of the lake in the US. So thus we have been relying on some American statistics to be able to kind of put that into a European context as well. Speaking first about traffic safety for emergency vehicles, we know that there are around 88,000 traffic accidents yearly that do involve emergency vehicles. And actually 43% of these traffic accidents are estimated to happen in intersections. So by that said, we know that there is a lot of accidents happening with emergency vehicles when they're actually trying to cross a signalized intersection where it's red. So this is like one of the main concerns for them when it comes to both the kind of work safety, but also in terms of traffic safety for everybody involved. And based on US statistics, we can actually estimate as well that this is the cause of 164 deaths on a full EU level. So by this said, we know that there's a big potential for traffic signal priority, where I think we could estimate that many of these accidents could be removed based on this. In terms of shorter response times, we have been doing quite a lot of traffic signal and traffic flow simulations during the project. And we see that traffic signal priority could reduce the average trip time by around 10% in urban environments. We also actually know from the Swedish MSB that there is a quite high saving in terms of societal savings of around 375 euros per minute saved. And if we would extrapolate this to European-wide implementation of traffic signal priority, there's actually 45 billion euros that could be saved yearly by just making sure that our emergency vehicles get to site a little bit faster. So there's a huge potential when it comes to traffic signal priority. And that's something that we really hear from our end users, and something that we actually can prove now more with data. So looking at our end users today, there's a big urge for getting traffic signal priority off the ground and out implemented in larger scale. And I think during the project now, we have seen that the technology is actually here to support it. So in NordicWay 3, we actually fully incorporated traffic signal priority into the EVAN platform. So this means that emergency vehicles tied to us as a platform today, which we said, just looking at the Swedish market, it's more than 100 municipalities. They can, with the push of a button, already now get going with traffic signal priority for all their vehicles without any larger investment or anything like that within the vehicle. The stuff is already there. And for us now, the whole solution is ready for a large-scale deployment. But of course, what we are waiting for is the infrastructure to be in place. I think we're seeing municipalities and road owners taking steps towards this, which is great. And we're seeing steps taking towards establishing an interchange for the longer period of time, which is also great. But I think now it's really kind of time to get going with this. And I think that has been our message and conclusion from the NordicWay project as well. So with that, I think I'm leaving it back to you, Thomas.
Thank you. Really good time management as well, Mikael. So continuing on this commercial perspective, we're moving a little bit deeper into technology and moving into the thematic area, technology and readability of TSP solutions. The next speaker is from Swarco, and his name is Daniel Lesowski, who is currently a sales executive at Swarco, bringing experience from previous roles at Swarco, GMW Innovating Solutions, Grupo Feralia, and Grupo Aldesa. Daniel holds a Master of Business Administration MBA and has skills in including civil engineering, business development, analysis, development, and project management. So please, Daniel, go ahead and please take control of the presentation.
Good afternoon, everybody. Hope that you can hear me well. I hope to have a good time management as the previous speaker. So looking at the clock, let's see if in 5 minutes I can summarize a little bit what we have learned and also how we have contributed. So for us, as the technology supplier, we see traffic light priority from very different angles, both from different users groups as well as from different countries where we deploy that service. In NordicWay 3, we have been involved in 3 pilot sites. 2 were involving traffic light priority for public transportation. 1 was dedicated for the emergency vehicles. However, in other geographies, we also look at the freight, at the vulnerable road users like cyclists, and so on. So traffic light priority has many phases, and from that perspective, it also comes with a lot of complexity of also acknowledging the existing traffic management rules, end user preferences, the way that basically the traffic and transport of goods and people really moves per city, per country, per region. However, the advantages, they stay the same, no matter the architectures or the technology behind. What we have discovered or what we have prepared as Swarco for the Nordic countries, during those pilots we have learned and created 6 different ready-to-deploy architectures that are basically standard deployment, also following the European open standardization like at CC roads. And from our perspective also, what is critical is to have that compliance for all the road users and road operators or fleet operators, fleet owners, to talk the same language, because at the end of the day, we are looking at large-scale deployments, as Michael was also mentioning. In the essence, the biggest benefits are not on those isolated small-scale pilots, but really when we talk scale, huge operation nationwide, where this particular services can only help and benefit. So the use cases are bringing particular improvements, particular benefits for different group users. What we have learned, obviously, is from the emergency vehicles, there every second counts. And Michael was very kind to quantify also how much of the benefit can it bring to traffic safety because of the preemption capability in which you just give the green light and preempt the intersection, knowing where the emergency vehicle is heading for all the road users to safely help the blue lights efficiently move through the city with the lowest possible also disturbance in the traffic, because this from traffic engineering is really what we care about. From public transportation, I would just add that one of our pilot sites, we see reduction in the travel times of up to even 35%, improvement of the punctuality to even 9%. Therefore, if a city is looking for a solution that helps encourage people to change the modes and go towards the public transportation instead of their own vehicles, this is also a really good mean to improve the reliability of the service. In the whole Netherlands, we deployed public priority for freights, so that we encourage also the lorries, the logistics, to move outside of the city centers get priority in the outskirts of the city, lower down the emission and improve the traffic flow, not having those heavy goods vehicles. Also bringing to the table benefits for the fleet operators, like the lower consumption of fuel, as well as the wear and tear, because of the lower amount of stopping that these vehicles will then encounter. What is really important is that each and every city regulates its traffic on its own. So the technology has to be elastic, has to be deployable in such a way that we encourage currently what is the most important shift for the city. Like, for example, for Paris, where we deploy priority for cyclists in the city center. This is really critical to encourage people and to understand the traffic better, yet knowing that the technology can be helping handle. And what we also sign is, like Michael was saying, currently we look for large-scale deployments. So talking one language in different countries, using open standards, using specification, using those lessons learned from NordicWay 3, and deploying the same type of capabilities. So a platform that can only grow in different locations. As of today, we serve and prioritize almost 9,000 vehicles in the Nordics, and we are very keen to also go towards the CITS ready future with a smart Prio, which very many of the transport operators already know in that geography, so in that region. Yet, really looking forward and really thanking, congratulating all the partners that were involved in those 3 years of deployments and sweat and and tears and blood shared together in those projects to make them a reality. And looking forward for next steps after the NordicWay 3, which for us is reality and bringing CITS to the streets in scale. Thank you very much, and passing the ball to the next presenter.
Thank you very much. So, moving from Svarko to Technolution, and let me introduce the next speaker. Let's see, now the presentation just disappeared, but Alvar, could you please share it again, please? Meanwhile, Edwin Main has a master's degree in computer science and started his career in space technology. Quite soon, he transitioned to the magical world of traffic engineering. As a domain architect at Technolution, he explores traffic prioritization and optimization solutions in the Nordics, the USA, and beyond. So with these words, and when we will get the PowerPoint into your first slide, I think it's many slides ahead. Let's see here. Edwin, you can take control perhaps of the PowerPoint. Oh, there we go. Excellent. So Edwin, the floor is yours.
Thomas, thank you very much for that warm welcome for this introduction. 5 minutes, so that's really short to comprehend all what we've done in the NordicWay 3 project, but let's give it a try. So we are Technolution, I'm Edwin Main there, and we worked on the hybrid traffic signal prioritization solution. And hybrid is about using what's already there and see how we can use existing equipment and extend it to traffic signal priority. Looking at the picture, it looks like this. And our goal was to exactly do what I just said, use existing legacy equipment, so not installing new hardware, and you then using standardized protocols, meaning the RCP protocol and the ETSI mode protocols from the CITS and the C-roads parts, and use that information to create this kind of traffic signal prioritization system. And we already had the 2 modules for that. One is the priority request generation that can take information from a bus or emergency vehicle and generate a priority request. And the other part of the system, the priority request service, that takes a request and brings it down to the actual traffic light controller. And we extended that with the connection to the interchange node for the NordicWay 3. making it a standardized ETSI hybrid solution. And how does that look like? It starts with collecting the data we can get from the buses. So we had a connection to the traffic lab system, getting collection of all the buses and their locations, so we know where are the buses at this moment. Then we added virtual reporting points on the road that says, hey, if a bus is at that point, send out a priority request. And that's what we did. So you can have a pre and a near the intersection or a cancel message, all part of a priority reporting point. And that's what we configured into the system. So once the bus hits such a reporting point, we create a message by the priority service generator, send it as a standardized SRAM message to the interchange node, and the request is out in the world. Then on the other part, the priority request service collects all those messages, receives all the priority requests from the drivers, from the buses, but also from emergency vehicles, and converts that and translates it, like David already mentioned it, translates it into an RSP command. And that RSP command is sent to the actual traffic light controller. That in its turn will react on that and gives the priority to the requested and desired movement for the bus. And that means that the complete loop is then closed. So the bus is being detected at the reporting points, messages are created and sent around, and at the end we are instructing the traffic light controller, please give that priority to that particular bus or other vehicle. And then that's our part of the hybrid solution. And also, like the other speaker already did, what were our findings and recommendations about this project? First of all, a hybrid approach, like we explored here, works. You can use existing infrastructure without adding new equipment and buses or new equipment at the traffic light controllers. The equipment is already there. The only thing you need is more software, some cloud services to bind it all together to make it work. And you can reuse the existing components, and if you then add the standardized protocols, like the ETSI protocol and the RSP part, you can create that scalable and sustainable solution for traffic signal prioritization in regions and cities. Also, that standardized protocols ensure that we are still interoperable with other supplies. So it can be our own messages, but also from EFM and other kinds of messages about priority requests. The other thing we learned that the actual message to get priority is a standardized message, but it missed some elements, and we added that in a rather time-consuming process, because we find out that adding and changing the ETSI messages, that's really magical. It's really a magic world of extending that and making sure that we both ends are understanding what we are talking about. We succeeded in that, and my advice would be, let's bring that extension also to the ETSI advisory board and see, hey, can we extend the messages for this particular priority request? And maybe start with a Swedish profile, extend on that one, but then go to the world and make a UI, EU or even world profile for it. So I tried to keep it in the 5 minutes. I hope I covered that. That were our findings and recommendations. Dit was uit de mind voor Technolution, and back to Thomas. Thank you.
Excellent and well done, Edwin. And Edwin, as you started your career in space, we will remain on high altitude, moving on to the cloud. And so let me introduce you the next speaker from Monoch, who is Nicolas Mercier, who is a deployment manager IT at Monoch. Nicolas is a seasoned professional in IT deployment and project management, and stands out as he speaks French, Turkish, English, German, and Dutch. So please, Nicolas, go ahead.
All right, hi, thank you for the introduction. So what I will do is, you already had a good presentation on the interchange and what we also delivered as Monoch in the previous session. So here, within the short time frame that I have to go a bit more in deep regarding the traffic signal priority, I will try to translate what we understood here, what would be necessary on top of being the interchange. So what we did, right, is we provide this data broker, data exchange platform that would allow all the messages from the roadside equipment to the service provider to communicate between each other. On top of that, this would happen with, of course, a level of security, a level of governance and control. What we can see in this is that this interchange is also bringing European standards, right? So what you understand is that there are European standards like the C-roads that are required, which allow a more comprehensive and a balance, an equilibrium for all the messages that are created and used to make sure that we all communicate on the same way. What is important also to understand is that with this interchange, we are able also to connect the roadside equipment with the subject interface. So what does it mean? It's like this is an interface that can be used alongside the control interface, the RSMP that was presented before, which is the most used message for the Nordics, and it adds this additional security level as well as warranty this low latency, which is kind of a technology need when you put in place such a platform. I'm going to the next slide. We as Monoch, what we learn is that, of course, and I think everyone agrees on this point, like the interchange is a need. You have to have this kind of a hub party that is able to connect all the different actors with a technology that is ready, a technology that allows standards to put in place, EU standards, so ISO norms, C-roads, etc. And on top of that, you want this platform to be able to provide a bit of feedback, a bit of visibility. So this is one of our also extra lesson learned, is that on top of being that hub data platform that enables those message exchange between the different parties, there is a need also for better visibility onto those messages. And this is more for either the road authorities in terms of governance, for the municipalities in terms of understanding for the intersections, for the service provider in terms of understanding the data that they're sharing. So that is something, again, that is technology ready, but the interchange has a specific job. And going further into details with the analytics and the reportings will need adding new features. And for that, we as Monoch have already developed a solution called Telex that would be a good addition on top of this interchange solution here. So what you can see pretty much on the right side is what would it look like as a simplified flow. You already had a flow presented before with the different partners. But what happens, you have your traffic lights that are connected with RSMP messages, and this is being translated into CITS, C-roads format that enable the service provider that are European standard compliant to also feedback and communicate. And here in the case of traffic signal priority. So this is what would be our takeout, is that the necessity of an interchange, the fact that it has to be, it's technology ready, the fact that it's pertaining the European standard, and as well as providing the extras with analytics and possible extra features to understand what is it that you are providing as a messages through that interface. Thank you.
Thank you, Nicholas. You're excellent at keeping time as well. So now to wrap this up with a final presentation, and what we all have been waiting for is the conclusion and findings from the pilots and the end goal of implementing TSP. And this will be done by Petter Eistrand, works with ITS, CITS, and is specialized within traffic signals. Petter has a background from public transport ITS and a traffic signal supplier. So please, Petter, go ahead with the conclusions.
Thank you, Thomas. So these are conclusions. I've been having the common project managership with along with Thomas here, and been doing most of the technical, been involved in the more technical parts of it. So some findings and conclusions from my part gathered along with the participants have been that, oh well, I have this in the I don't know which presentation you have, because I have it online. Here is Alva, can you please reshare from the SharePoint, because there are the conclusions in the presentation there.
Yes, I will share the right one.
Yeah. So I can stop sharing and you can do the
Yeah, and meanwhile, while you share, I'm gonna say we have exceeded by a few minutes, so I know the next session will start at 2, but I would suggest perhaps you take at least 1 minute stretch before that.
The next one starts in 10 past, I think.
Oh, okay.
So let's see now if we go to slide number 42. So let's see, how do we get there? I'll take control. So a bit of, do you see the slides changing now?
Yeah, we have
quick
benefits, Uppsala.
manner. Let's see how we can get to 43 in a quick bit.
It's good with a quick run through. Okay, next session starts at 2:15. Okay, so then you get the break. That's excellent.
So now you get a quick summary of the presentation. So if you missed something, give you the opportunity to relearn. That's good.
Yeah, we're moving on.
Yeah. Closing into number 42. And there we go. So first of all, the finding or the conclusion, which is quite obvious, is that in order to have this TSP service up and running, as for all the other CITS services, we absolutely need the interchange in place. So if this goes down, we have no CITS enabled priority service anymore. So this is the main takeaway. And also that we have concluded that TSP is very easy to scale up. Once you have put any key infrastructure in place, such as the interchange and the services on both sides, then it's very easy to extend the service to more intersections. So it's very, very scalable when going to standardized solution like this. We have been working a lot with the architecture, and we have seen that there is no full, like a manual for the architecture. There's a lot of things to be put in place on a national level. So that's what we have spent a lot of time doing. So in order to do our local deployment, we have had to do some local adaptations. This also made it possible for us, as has been presented with the RSMP protocol, that we can reuse legacy equipment that is not CITS enabled with the roadside ITS stations. Also, we have seen that the architecture tends to be quite complicated, and the integration work in this pilot group has been quite extensive. So we believe that more testing will be needed before we are up and running in a full-scale deployment. So, and all has been mentioned before, everything CITS is based on all these standards and specifications that are, as David said, they're cross-referenced, and you can read the reference to one standard in one specification, and this one in turn will refer to another specification. So some kind of reading guide would be nice, so that everyone understand what this is all about. So, and we have also used the ETSI messages, and we have added local data into it, and this might be an idea to bring this to the further development of the C-road specifications. So final words from me is that it has been a bit of a struggle to get this in place, but we think we have quite a common view on how to do this. All right, and by this I'll give the control back to you, Thomas.
Okay, thank you, Petter, for those findings and conclusions. So now I know the next session starts in 15 minutes, but for those of you who would like to stay and have some Q&A, please raise your hand and I'll let you in. And while you're thinking about the question, I will have a first question to Trafikverket and David. What would you see the greatest expected benefit by deploying the TSP service?
Yes, from the Trafikverket's perspective, it would be that we no longer have a need for any special equipment in the intersection for achieving priority, which is the case in many places today. We can rely on this CITS platform to provide all kinds of functions, including priority.
Thank you. So we have no more questions in the chat, and we have actually delayed a few minutes. So I guess we should tie this session up. I'll just wait a few seconds if somebody would like to add or ask anything. I also know the chat has been intensive by questions and answering in the chat, so that's good energy. So, okay. Thank you all the speakers for today's webinar about traffic signals. Good luck in the future endeavors. So thank you, and let's meet up at the next webinar. So there I close this webinar. Thank you very much.
Thank you all.
Thank you, Thomas.
Bye-bye.
Thank you.
Thanks,
Bye.
Thomas. Bye. Thank you all. And Alba.